Hello, and thank you for joining us today. I'm Gordon Bell, Vice President of Marketing at Energis Corporation. And today we'll be hearing from Neeraj Sahajpal, Senior Vice President of Marketing and Strategy at Energis, and Dinesh Katani, Senior Principal Analyst for Wireless Power and Power Supplies at Omdia. Our webinar today is focused on the very latest technology announced from Energis, the WattUp PowerHub. During the webinar, we'd like to invite you to submit questions by using the Zoom Q&A function. At the end of today's presentation, we will have time to answer many of the questions that you submit. Our agenda for today is the following. Dinesh Katani will speak first about the opportunities for wireless power and long distance charging.
Neeraj, if you can put the agenda, please.
I did.
We will then turn over to Neeraj Sahajpal, who will speak about the Energis Corporation background, our very latest announcement, the WattUp PowerHub, as well as other recent announcements from Energis. And then finally, questions and answers. I'd like to now turn it over to Dinesh Katani.
Thank you very much, Gordon. Once you're ready with the slides, I can.
Yeah, sure.
Just a very brief introduction. My name is Dinesh Katani. I'm the lead industry analyst at IHS Omdia, which is erstwhile IHS Markit. And today I'll be talking about the long distance wireless power market, what are the opportunities in the market, and how big the market is in terms of the unit shipments, if you talk about that. Basically, when we look into the next slide, what I have here is look into various aspects of the wireless power market in general, and then I can then deep dive into how the technology is evolving from one end of the segments to the another end. Next one, please. About Omdia. Just very briefly, I will let you know about our company and the work that we do in the wireless power market. As many of you might know, Omdia is the #1 quoted market research company on wireless power. We have around more than 11 years of experience of doing research in this particular market segment. Again, thanks to our work that we did in the prior company, IHS Markit. With regards to the scope of our research, what we cover currently in the wireless power market is we have around 30 applications which have shown current and potential applications for wireless power. We cover all the technologies, whether it's coupled, uncoupled, whether it's low frequency, high frequency, and whether it's also long distance charging. Then we also have, what we have is provide market intelligence to companies and provide strategic guidelines. We are also the company who are subject matter experts, analysts are also invited at key industry conferences and trade shows to public or to present the market scenario and outlook. The product that we have on wireless power is called the Wireless Power Market Tracker, which includes market sizing, forecasting, data analysis, support also that we have there. We do customized research and also do sponsored webinars and workshops in this area. Basically, let's move on to what's the opportunity wireless power market. Well, the wireless power technology is evolving beyond mobile phones. We already seen mobile phones getting the grip of the market. And so as the market is evolving across applications, so is the coverage. So the list that you see on the screen is basically looking into all these applications which are currently into the development stage. Some of them are into market stage as well. And if you see the list, it spans across industries. We cover automotive segments, electric vehicle charging wirelessly, in-cabin charging, mobile phones, obviously, computing devices, laptops, tablets, smartwatches, smart home applications, home appliance applications, medical, robotics, industrial, and more important, also we cover the infrastructure market. That has been the coverage of wireless power and in our research, and obviously we also look into applications like power banks, e-bikes, and 5G repeaters, which is another emerging segments. Coming back to how the technology is evolving, like I said, there's a wide range of technology solutions which are adopting wireless charging. So there's solutions from using low frequency standards. We have a high frequency solutions, and we also have the NFC charging, and then we have the coupled technology. I'll spend some more time on the uncoupled technology a little bit more in the later. But as you see here, the market is already maturing enough with having wide range of solutions available for companies or OEMs to pick it up based on the requirements and what the user experience they want to create. Looking to how the market is evolving, if you see within the last 1 year's time, the last 2 years since Apple adopted wireless charging for their phone in 2017. Since then, the market has evolved. It has evolved not only within the mobile phone segment, but it has also evolved beyond mobile phones. So we already see in the last 2 years' time, wide range of applications looking into this technology, whether it's mobile phones, smart watches, earphones, power banks, reverse charging was one of the feature that we added, personal appliances, automated guarded vehicles, electric vehicles, public places, battery powered devices, again, that we have wearables, IoT sensors, and other type of applications. And if you see these applications are exploring technologies which are not only stuck to one particular aspect or one particular frequencies or one particular distance level, but it spans across the solutions there. So, from a technology perspective, yes, it has been evolving from the applications here. Then what we talk about, what happened in 2019 is also we saw extended standard. We saw not only we had key standard for mobile phones or low power segments, we also had a key standard which looks into specific kitchen appliances standard. That's also was introduced in the market, and that looked into power levels of 200 watts to 2.2 kilowatts using low frequency solutions there. And we also saw introduction of NFC charging in the last year. Then while the market was developing, there are more and more applications which are adopting wireless charging. We saw the power segments, the power levels were also getting segmented. And each of the power classes which were evolving were catering to specific applications. We didn't have one technology looking into all applications. So the market was getting maturing enough in such a way that there were solutions available for different technologies used by different type of power segments as well, and also by different applications. So that was another key segment of the market here. More so in the uncoupled solutions. When I say uncoupled, I mean distance charging. I mean long distance charging. This is where there's a big difference there's a distance between a receiver and transmitter. Receiver is the device which gets charged, and the transmitter is the device which charges that particular receiver. So that is the market. And over the last 2-3 years, more so in the last 2-3 years, there's been wider acceptance of the technologies happening. There's more and more happening in this scenario as well. And again, in the uncoupled scenario, we had quite many solutions available. We have RF-based solutions, we have ultrasound-based solutions, we have IR-based solutions, and there's also a good aspect of energy harvesting, RFID being used in this spectrum of the market as well. With regards to the standard that is currently available in the market, we have a full aligned standard currently for RF. Saying so, there are also other proprietary solutions for RF, IR, and even ultrasound. And with more on the uncoupled technology, if you see here, there's a wide range of power segments that we're talking about, from a 10 milliwatt segment device requirements to a 20 watts charging. And again, as the market is maturing, the solutions provided to the OEMs, to the consumers are also varying. We have near field solutions, we have companies promoting mid-field solutions, and companies who are providing far field. And that ranges from a 4 centimeter to even 4 meters across the room type of solutions here. Not only that, even in the uncoupled technology, what we saw in the last 3-4 years, thanks to the wider acceptance of the market or the excitement in this segment, is that we look into many players entering this market. So we have companies looking into RF, companies looking IR, and all those things. So there's a lot of excitement, there's a lot of work happening in this market, which showcases how interesting the market is and how accepted the market is, or how ready the market is in adopting this in the solutions here. So that was more on the technology landscape here. Let's look into how the application is moving forward. Yeah. So basically, what we see in 2016 and 17, just to give you a background here, we only had 2 applications there. Smartphone, end of 2017 is where we had the smartphone. And before that, we have a legacy electric toothbrushes, which has been using this technology for the last 10-15 years. So that was a scenario in 2016 and 17. Within 2 years' time, what we see in the next slide basically is how the market has evolved. It has evolved from only smartphone to smart electric toothbrushes to other technologies, wider mobile applications as well. Yeah. So within the 2 years' time, as I've mentioned, the spectrum of wireless power changed. Adoption increased beyond mobile phones. Within the mobile phone ecosystem, we had not only had mobile phones, but we have wireless earphones, fitness trackers, power banks, in-cabin car charging, integrated furniture, smart watches. Then we also, within the appliances, beyond electric toothbrushes, we had interest in electric shavers, electric, what do you call as robotic vacuums, small kitchen appliances, power tools. Then we also saw a wide range of variables picking up this segment as well, adopting wireless power or showing interest in wireless power. We have like fitness tracker, earphones, smart watches, smart glasses, smart clothing applications getting interested with that. We also saw a good interest coming up in the IoT sensors market. Again, that was another big segment there. And while we were talking about 2019, here we have in the next 2 or 3 years' time, these are the applications, these are the industry sectors which are geared enough to pick up wireless power. Again, for them, they have a range of technologies to pick up, they have a range of power segments to pick up. And as the market grows, as the opportunity grows, there'll be place for each of the key players in the market. It's just that how you fit up each of the applications into the right technology and the right power levels is what is it. And again, if you see the plethora here, we even have defense, we have 5G, we have computing devices, looking into wireless power, medical devices, industrial areas, automotive, mobile ecosystem, and infrastructure. So from this slide, it shows that how the wireless power market is basically broadening its scope into the market here. Then let's look into specifically into the distance charging. How big is the opportunity and how big is the size of the market? Before I go that, this slide basically talks about the total wireless power market. And that includes the receiver and the transmitter. That includes low frequency applications, high frequency applications, and it includes uncoupled technology. And if you look into the 2018 picture, there were around 563 million units of wireless power receiver and transmitter cumulatively sold in 2018. And that's expected to grow to 1.9 billion by 2023. And by 2028, because we also do 10 years forecast, we see around 4 billion units of wireless power units sold in the next 10 years time. And if you cumulatively add up all these devices which will adopt wireless power, the total market opportunity is to 21.7 billion. So that many units of wireless power receiver and transmitter that will be shipped in the market. And that only includes 30 applications which we are currently doing research on. There are many other applications, very niche segments, which are still not a part of that. So you can see how big the market is at the moment here. Yeah, the next one, yeah. So this particular slide talks about uncoupled technology. It talks about long distance charging here. And again, if I categorize low distance charging and put them into a less than 5 watts segment there, if you see the market is expected to grow from nearly negligible in 2018 to 81 million by 2023 and 576 million by 2028. And cumulatively, around 1 billion units of receiver and transmitter will be shipped in the next 10 years' time, only using uncoupled technology, only looking into long distance charging solutions there, whether it's RF, whether it's IR, or any other type of solutions there. So that big is the market structure there. And to just give a wider picture, not only looking into the uncoupled technology, let's look into the 0.5 segment, a bigger picture. And even some of the companies working on the uncoupled technology or long distance charging grab a wider share of the market. We are talking about 7.8 billion units that will be shipped between now and the next 10 years' time. So this is more about how big the opportunity is for wireless power. This is how big the opportunity is for long distance charging. And yes, there are players who are talking about it. So this is here from me. Obviously, please shoot in some questions if you have on market sizing, either of this technology or not. Again, when you look into these pictures, when I look into this picture from 0 to 5 watts, I have listed earlier some applications here. The next slide talks about which of these applications I've highlighted in the yellow, which of these applications are very relevant for wireless power, for very low power segment, for long distance charging, uncoupled technology. And you see that there's a big list out there. So as I said, the opportunity is quite big enough. It depends on how you promote your product, how you position a product, and get the right solutions to the OEM so that they can provide a better user experience, and they can also provide enhancement to their businesses, because adopting wireless power is not about putting coils or antennas or solutions or components into a device. It's more about providing solutions how business can gain from wireless power, how enterprises can gain from wireless power, how consumers can gain from wireless power. It's all about the opportunity there. And depending on how you pitch it, how you sell it, and provide it, package it for your consumers, we have the winner there then. Yeah. So that's it for me. I will now pass on to Neeraj, who will talk specifically about the solutions that he has from his side. And while Neeraj, yeah.
Okay, as I say, before we head over to Neeraj, I'd just like to also ask those participating, please do use the Q&A function to send any questions you have. Once again, at the end of today's presentation, we'll have a Q&A section.
Hello, everyone. Welcome back. And I hope everyone is doing well and safe and trying to navigate the new normal of the COVID-19. First of all, thanks to Dinesh. It's always a learning experience listening to Dinesh. I've talked to him many times about his perspective about the market. He has a strong experience in terms of seeing how the market is evolving for the last 10 years. My takeaway from Dinesh is that phone is not the only market. We sometimes only think about phone charging as the only opportunity. That's not true for the wireless charging, especially the at distance charging. The opportunities are far more interesting in other segments also. The second takeaway I had was that wireless charging 1.0, which is the Qi technology or short distance technology, has really created a market. And what the wireless charging 2.0 or the upcoming technologies are going to complement what has been achieved by wireless charging 1.0. So we are starting from a point where the need has been established, and now the market is moving toward how the user experience can be made better. Having said that, so I would like to start today's session with a roadmap of what we'll cover today. There are many people have joined first time, so we'll cover short section on what Energis is doing, what's our thought process on RF charging is. Then we'll quickly switch over to our recent announced product, WattUp PowerHub. What are the market opportunities, what the technologies are, and how you can participate in the ecosystem we are going to build. Then we'll talk about some recent announcements and what's the relevance of those announcements. These announcements are basically between the last webinar we did in April and as of today. And then there is a section we see a lot of questions coming from you. Thank you very much. We see that coming from all the channels. Social, you send those questions directly to us. I have listed about 10 questions, and every webinar we're going to take these questions and give you more information how we are seeing the market and the product and how they will evolve into different market. Okay, so let's start. So Energis is a RF charging pioneer based in San Jose, California. We have about 50 employees. We are focused on bringing wireless charging 2.0, which we think is an extension to what has been established by technologies like Qi. We have exclusive partnership with Dialog Semiconductors. In a big picture, we are a business unit outside Dialog, where we leverage the Dialog sales and manufacturing for our chipsets. A lot of time I get asked this question, so whom do you think Energis is? At the core of Energis is the fabless semi company. Our business model is that we would like to sell our chips. The chips have been done in a wide variety of technology like CMOS, GaN, and GaAs based upon what the implementation is. We understood very early that unless we have the complete solution from all the way from the power amplifier to the rectifier, it is very difficult to provide the solution benefits. So we have developed technologies all the way from transmitter IC, power amplifier, receiver ICs, beamforming, non-beamforming, including the antenna technologies. But at the end of the day, if you look into any semi companies, you have to admit you need to provide the complete solution. Dinesh also alluded to that in his talk. Unless you can prove the whole package works, it's not possible to really sell your chips. These chips are not driving towards a standard protocol like Wi-Fi or Bluetooth. In fact, Wi-Fi in the initial years was a system play. Then it morphed into a semi-play now because the technology matured. We work with multiple partners in diverse segments. Our thought process is we need to enable the ecosystem. Today, we are working in more than 11 segments where we work with leaders in those segments and continue to push the technology so that in future, all these segments can come together and an ecosystem can be established. Our claim to fame is the first Part 18 certification for Power at a Distance, December 2017. In fact, in my talk, I'm going to talk about difference between Part 15 and 18, and there are some questions around what power levels are allowed. I will talk about that later in the presentation. Today, we are approved to ship in 112 countries, including EU, Japan, and North America, and we continue to work with our partners in China and Korea to get the last 2 markets approved. The technology is very well protected by a significant portfolio of patents. In fact, most of the RF patents or RF key technology component have come from all the work of engineering team from Energis. We are an active member of the Airfield Alliance. We were the founding chair of the Uncoupled working group where all these technologies are being developed. And we are also the board member at the Airfield Alliance. I also welcome you in the first week of June. We are doing a webinar with the Airfield Alliance where we'll be talking more about the frequencies, impact of Airfield Alliance, and how RF is going to shape the Airfield Alliance offering. Our vision hasn't changed. When we started this journey in 2014, we were talking about charging at a distance. We have been humbled during the process. We learned a lot while working with many partners, but our vision hasn't changed. We may be taking one step at a time, going from a near field to mid field to far field or smaller power to the higher power, but our vision remains the same. We are all working towards a day when the wireless power will be as ubiquitous like the Wi-Fi. And we really believe the component we are putting in place, the roadmap we are putting in place, that future is going to come. So let's just talk about a new technology. Whenever you look into how the new technologies have come to the market, you can look into the histories for 3G, LTE, Wi-Fi, various versions of Wi-Fi, any kind of these technologies. They've gone through a phase where multiple forces have shaped what those technology will become. And the way we look at it is that these forces are market forces, which are defined by customer application and their requirements. They continue to push towards that what customers are looking for, how the requirements are changing or may change over time. Then you start to look into the companies who bring the technology capability into that. And then in some markets, the external forces are very important. The external forces can be in terms of competition. It can be in terms of competing use cases. But in the case of RF, it's the global regulatory approvals. What we have found over last 4 to 5 years, that what the wireless charging 2.0 is able to achieve today and how it's going to shape moving forward is defined by these few forces. And we are very blessed. We are working with many partners over the years who have given us good insight into how the different kind of application or segments require the use of wireless power. We are blessed to have a technology team in Energis who understand the antenna, who understand the system, who understand the chip. And then we look into the regulatory approvals. Once we put that all together, the confluence of that is what the wireless charging 2.0 capability is, the roadmap is happening. So this is the summary of our 5 years of experience. We have mapped, Energis is the first company to map the whole RF landscape. If you look into this chart, on the x-axis, we talk about the transmitter to receive distance, and the y-axis, we talk about the receive power. That is the power at the battery after the PMA. You can start to look into the requirements is not monolithic. Requirements are very different for a device which is 10 milliwatt, for example, the sensors, you can have 50, 60 milliwatt, which is the hearing aid. Then you have 100 milliwatt. You can have fast charging at 250 milliwatt or 500 milliwatt. Then you have phone going all the way to 20 watt and 40 watt. They are not same receiver. Their requirements are different. At the same time, if you look into the different applications, the industrial and IoT and the retail IoT market, they're more like a longer distance, which we call the zone 8, which is the harvesting application. If you look into the gaming or the desktop applications, they're more like zone 5, which is the midfield application. And then you start to look into that the requirements are really shaping what is required for these products. At the same time, the technology that is available, for example, CMOS power amplifier is the lowest cost power amplifier technology available, say up to 1.2 watt. But we have technology that is developed from the GaN power amplifier that goes all the way to 40 watt. So we need to deploy a different kind of transmitter receiver solution to get access to all these markets. But our vision is that on the same vertical, for example, the near field or the midfield and the far field and harvesting, same receiver should be able to get the power from different side of transmitter. For example, you can have the fastest charging rate at the near field, and then you go to midfield application where the transmitter is changed. Now you can get more distance, but less power. And then you go to far field, you get more distance, less power, and then harvesting get least power. This is physics. The longer the distance is between the transmitter and receiver, path loss is going to be significant. Does this mean the technology is not useful? No, that's not true. We are finding out from our customer application. I can actually put a sensor network or any kind of a retail smart tags in a harvesting application or even the far field application. But at the same time, the gaming application can be in a midfield use case, and a phone can be near field. While phone can be near field charging at say 20 watt, it may be charging in midfield at a 500 milliwatt, or far field, maybe that's not the right application for the far field. So as the time progresses, the technology capability will increase, regulatory constraints will become better, more and more use cases will come, and we think an incremental roadmap is the only way to go and address these markets, and that we have adopted an incremental roadmap. We are attracting a different market. We are focused on wearables, smart glass, hearing and hearable, medicals, and home IoT for now, while we continue to develop the other long-term opportunity. And overall, as Dinesh mentioned, the opportunity remains pretty strong. Our benefits are that we do not really use coil. It's a very simple implementation. The receiver design is very simple. We can place our receiver in a lot of flexibility and orientation, and in terms of placement, we can charge multiple devices. We really do not need USB and pogo pin type of connection. And in this COVID kind of environment, the new normal environment, we are seeing that more and more devices wants to be hermetically sealed. So that's the RF application are going to be the charging choice moving forward. As I said, the core of the company is a fabless semi, and we have developed a strong portfolio of solutions, as I'm showing here. These are best-in-class technology. Transmitter, we have significant integration on the CMOS chip on the transmitter. We have a beamforming solution that allows us to have farther distance and more power. Then we have the power amplifier all the way from 1 watt to 20 watt, receiver from milliwatts to 20 watts, and significant portfolio on the antenna design, which we enable to our customers. And all that is rounded up with the software that allows us to provide complete solution, where on the app you can measure the powers, you can see how the power is interacting with different devices. We have established a partnership which we can name. We have a strong relationship with SK Telesis, which are spearheading our Korea push, including the POSCO, which is our industrial application. Primex is our ODM/CM partner, which is helping our customers to ramp faster. And then we recently announced the e-ink market for the retail and industrial applications, especially the smart tag. And I talked about the Dialog Semiconductor. We're very blessed to have that relationship that allows us to focus on how we develop the technology, while we let Dialog help us on the sales as well as on the chip operations. So let's just talk about the PowerHub. So before I go into the PowerHub, let me take you back to what really PowerHub is. PowerHub application, which is a set of technology that we have developed that will address up to 15 centimeter here and a power zone of 250 milliwatt. The simplest use case you can think about is a smart speaker charging various type of audio and other devices. So let's talk about PowerHub. The most of you have asked this question: is this the only form factor? The rectangular shaped speaker? No, that's not true. We are actually integrating this technology into various smart speakers, gaming console, desktop speakers, and looking into the Wi-Fi access point and set-top box. Gone are the days when the access point and the set-top box used to be in a closet. Now you see them on your desk, and these are devices which we're targeting. And the other device which we're very interested in is teleconference equipment. Imagine someday the Polycom type devices are sitting, and then you're charging your devices from that. So what exactly is the PowerHub technology? If you look into it, that we have been talking about beamforming. Let me state that very clearly. This is not replacing beamforming technology. This is very complementary to the beamforming. What we wanted to do was go to the basics of the product. For a shorter distance application, what is the size of transmitter we are looking at? What kind of power we are looking at? What is the use case which customers are asking for? And we realized that for a small, low-cost transmitter application, it is important to have less number of antennas. You need more number of antennas for the beamforming application, which has a place for a longer distance and longer power because of the beamforming gain. So this technology is targeting a charging zone of about 15 centimeter, although it can actually go to 30 to 40 centimeter also. And the whole focus was the 3 Ps of the product, that it has to be cost effective so that it can be deployed easily, or it can be implemented into these category of devices. The current device which we have can go all the way to 5.5 watt of transmit power, not the EIRP power. It's a transmit power. But we have the technology that can scale to even 10 watt and even higher also. The technology that we are showcasing today will have 5.5 watt of transmit power. It have the charging zone of 15 centimeter. It's very optimized in the cost and the bill of material. And if you want to know more about what the bill of material looks like, please reach out to us and we can give you all those details. The key part is single power amplifier, single RF path antenna, and non-beamforming. Why is that important? When you have a single power amplifier, single antenna structure, you have a very small size. You can actually go towards a low cost implementation, and it can be easily integrated into these devices. You do not need to buy a separate transmitter. Basically, you can integrate into the category devices we're talking about. And that allows you to have a solution which is very scalable. The way the vision we have is WattUp PowerHub is where user will bring their devices to get charged up. The opportunity can be in terms of ecosystem that can be developed from an OEM, from OEM to OEM device. But in addition to that, external devices that can be charged from OEM transmitter. For example, a smart speaker from a large OEM can charge key fobs from different car vendors, and that ecosystem start to happen. We start to see a lot of interest in this technology because it's addressing the user experience of charging multiple devices in a very cost-effective way. So from the perspective of the benefit, right? I did talk about the lowest BOM, but there's one very important aspect about it. It is based upon the FCC technology that we recently got approved. We continue to work towards how do we get more and more devices approved from our customers. The design can be implemented in many form factors. It does not need to be in a rectangular shape. It can be in a cylindrical shape. It can be in a thinner shape. And we have developed a lot more antenna portfolio that can actually fit into those designs. But the goal is very simple. Charge multiple devices, hard to charge devices like your glasses. bigger headsets, and the flat remotes or the key fobs, odd shapes of key fobs, 90-degree charging of the watches at a distance, and then you can just drop and the charging will happen. In principle, closer you go, you get more power. And I'm going to talk about the receiver impact on how the power is transmitted, because a lot of you have asked about that. Let's defer that question for now. So let's just talk about the structure of this design and how you can implement this. Starting from the left is the transmitter design. We use Bluetooth low power as the control channel. We do not use the control channel in the same frequency. And that is very important discussion, because in the part 15, where the maximum power is 1 watt and you can actually do 4 watt EIRP, the main reason is because the communication happen in the same channel. We have decided as an architecture decision to use out of band signaling, because that will allow us to have higher power on the power channel. So we're using 900 megahertz as the RF channel between the antenna. And then we use the 2.4 gig standard BLE channel for the communication. That allows us to have higher power on the RF channel. The DA4100 is the integrated transmitter solution that controls all the transmitter functionality, including the authentication. What that means is that any other receiver which does not have Energis technology would not charge from the transmitter which has the Energis technology. So we have developed all these authentication protocols. On the power amplifier side, we have the
Okay, while Niraj takes care of that phone that's ringing, just like to ask those to please do use the Zoom function for Q&A. I'd love to get some additional questions that we'll be able to answer at the end of the call today.
Thanks, Gordon. On the power amplifier side, the PowerHub uses the GaN power amplifier technology because we want to go to higher power. CMOS power amplifier one can go only up to 1.2 watt, but they're the most cost-effective solution for the lower power application. Then you go towards antenna technology, which I mentioned is a single antenna. Then this technology has been developed. It's not just broadcasting the RF signal. It has the control over how far this signal goes and how the signal is shaped. And that has been developed, all the system approaches which Energis team has developed. On the receiver side, you can have one antenna or many antenna, depending on the diversity. They end up on the receiver, which is a CMOS receiver that can be in the QFN or in the WLCSP, which is as small as 1.7 by 1.4 millimeter. It feeds into the PMIC and then it goes to the battery. So when we talk about the complete solution, you could see we have really simplified the complexity. And in terms of providing you a complete solution that can deliver to you a very differentiated solution for your product. In addition to PowerHub, we also have 4 other reference platforms which are available to our customers. They are segment specific for the IoT tracker, hearable, which is for the smaller hearable devices, and the hearing aid, various kind of hearing aid. We have the reference design for that, and the smart glasses, which we started to see. These are all near field application, but same receivers can also charge from the PowerHub. How are we supporting a customer? As I said, this is a complete system solution. So we provide all the evaluation support, either providing the reference kits for our customers. We also understand how the antenna design requirements are. We provide the complete antenna design to our customer if they use our chips. We provide them all the engineering support required, for example, hardware, software, BLE porting, and we are porting BLE today in multiple solutions, all the way from Nordic to Dialog to Broadcom and others. And we help our customers in manufacturing, because once the design goes through engineering build to design build to production build to mass production build, it goes through a level of understanding of the yield that can only happen by having a closed manufacturing support. In addition to that, we have a full-scale regulatory lab where we can provide the pre-scan before you go to actual approval that allows your actual approval to be a shorter cycle. We also support the on-site for all the testing lab. If you have any question how you can get access to these technologies, please send an email to sales@energis.com and we'll happy to answer those questions. Okay. These are the two products which are coming to the market. We have already announced Delight, and the new sound has been announced. It should be available to customers in June timeframe. And this is the first BLE-enabled wireless charging solution in the market. Our recent announcement between the last webinar and this webinar, we did announce the FCC approval for at-distance charging solution, similar to the technology which I just talked about, the PowerHub, single power amplifier, single antenna, all the way to 40 centimeter. This approval, you can get all the documentation that on FCC website. We did announce the PowerHub developer kit, which we are enabling our customers with. We have started to see strong interest into engaging on this developer kit, and customers start to design for that. Then we added another vertical, which is for the health for the equestrian. And that product is also ramping up quickly. Then we announced the partnership with E-Ink, the smart tech. So how does this really fit in? The first two announcements are very, very focused on the zone 4 from the chart I showed, which is the PowerHub kind of technologies, and how we can take the RF technology from Energis to longer distance also based upon a cost-effective technology. The next two are more focused on the customer. Number 3 is more immediate customer introduction. And number 4 is addressing towards a large retail market in a long distance charging application. So I would highly encourage, please send your question. In the meantime, I would like to address few questions that we have seen through various channels coming to us. And thanks for sending them. So let me take a shot at addressing them, and then feel free to answer any follow-up questions you may have. So the first question is, most of the time we get this question, so how much is the receive power? I think that question is not complete. The reason for that is very simple. The transmit is what, if you look into the regulatory approvals, in principle, they only certify the transmit powers. Receiver device is entered into a charging zone and then see whether there is any absorption effect or not. So receiver power is very much dependent upon the size of the receiver. What are the charging characteristics of that receiver? They may not be taking more than 100 milliwatt because the battery in those devices cannot get more than 100 milliwatt. So saying that the receiver power for specific transmitter is X is not a true statement. Receiver power for given transmitter power really depends on the size of the receiver, the antenna gain on the receiver, charging circuitry on the receiver, even the battery characteristic. Second question, that what is different between part 15 and part 18? And this is related to a question I saw that is it correct that our solution can only transmit 1 watt? No, that's not correct. And that question comes from the confusion on part 15 versus part 18. Any communication protocol, for example, our BLE protocol approvals has to be under part 15, but our the wireless power approvals all are under part 18. And if you look into the part 18, which is what the FCC is, the transmit power is not constrained to 1 watt. Even in the part 15, 1 watt is a conducted limit. With the antenna gain, it is actually 4 watt, which is what the Wi-Fi and the Bluetooth devices are. So yes, we can go and transmit more than 1 watt in part 18. As you can see in PowerHub, we are doing 5.5 watt. So what's the maximum transmit power? Similarly, it really governed by the regulatory constraints. For example, ITU might have a limit of 50 watt EIRP. These limits will change. But at the same time, if they're in a constrained kind of use case, there may not be enough limit. because, for example, in the military application or industrial application or robotic application, where the animates are not nearby, the powers can be more. So it really, you need to understand the whole context of the questions and then understand what is relevant. The other question is, are we replacing beamforming with PowerHub? As I mentioned, no. Beamforming requires a longer transmitter. It allows you to have longer distance because of the beamforming gain. But at the same time, PowerHub is an application-focused technology for a shorter distance, smaller size, low-cost implementation. And then we hear this question, what is really cost per transmitter and receiver? I can share with you the receiver implementation is very simple. It's a one chip, very small chip from Energis, one antenna, two capacitor, and a small DC to DC converter. Our customers are able to take this receiver solution and implement into their devices for less than $1 in 10,000 unit quantity. In a millions of this can be easily implemented in less than 50 cents. Now you can start to see the potential of it. Very low cost receiver, which can easily be implemented into all category devices, can coexist with the BLE technology on those devices and can be approved. That can be game changer. Then the question comes that why can't I use the antenna for a 2.4 gig and 5 gig and just send the power in those bands? That may not be the most efficient way of doing that. Because if you look into the antenna design for communication, they're very much aligned towards data communication. They're not aligned toward wireless power. Then the question is efficiency versus convenience. I agree. Efficiency at distance is going to be low, but the focus is not efficiency. If you're really looking for efficiency, efficiently charging your phone at 1 meter at the rate which you will get required, I don't think so you understand what this technology sets are delivering. It's all about convenience. It's not about how fast you charge. The paradigm will shift towards, I do not need to think about charging. And that's what is important about the wireless charging 2.0. And the charging time for various devices, it can differ. The charging rate depends upon what is your battery charging technology, what is your charging rate in terms of receiver power you're getting. So you cannot really say one device in the same location will have X power and the other should have Y power. They will be different. But the difference is coming not because of the transmitter technology, coming because they have a different charging rate from the battery, they're different antenna sizes. The other question, why it is taking so long for devices to get introduced? This is a new RF technology that has to go through the phases. We continue to work with our customers to launch these technologies, but we think the learning is good. Once our first set of devices are in the market, from there, the next set of devices will not take that long. It will be happening much faster because they will be climbing on the learning rate which you have done. And then the go-to-market accounting for global approvals. Yes, global approvals are needed, but there are enough market available in the approvals which we have for now for the US and EU and in Japan. And we continue to work with our partners in Korea and China to get those approvals. I've tried to address these questions quickly. Sorry about that. But if you have any question, please reach out to sales@energis.com. Our goal with these webinars and the blogs we're doing is to engage and provide more information on how we think wireless charging is progressing. Gordon?
Thank you, Rich. We'd like to go ahead and turn to some of the questions that we're getting from the folks that are participating on today's webinar. First question is the PowerHub. We mentioned that it only has one antenna. Does that mean it can only charge one device at a time?
No, that's not true. That's where what I was trying to mention, that you need to separate the transmitter and receiver antennas. On the transmitter, it has one antenna. On the receiver, each device can have one antenna, but you can charge multiple devices, as we show in this picture. Each receiving antenna can get the power from the same transmitter antenna, because there is a charging zone that has been established. So multiple receivers can charge from same transmitting antenna.
Great. Next up, 900 megahertz is the power transfer frequency. What is BLE used for?
As I addressed earlier, 2.4 gigahertz BLE, which is a standard BLE protocol that you use in all of your audio devices. 2.4 gigahertz used for BLE, and that's used for the communication and control. For example, transmitter needs to know what's the power level receiver, should they send the power to that receiver or not. That information comes via BLE from receiver to the transmitter. The reason we have chosen BLE because most of the devices which we are targeting, actually, in fact, 100% of them, they have BLE. So we are leveraging that protocol, which is very well established.
Great. Next up is, did I read correctly that your solution does not use coils or tank circuits?
We do not use coils. This is an antenna technology, any kind of RF antennas. This is a high frequency. The coils are typically used at a lower frequency, like kilohertz, and in some cases, small megahertz. These are antenna technology, like same way you communicate on your 5.8 gigahertz Wi-Fi.
Okay, next up, is the PowerHub frequency and power level compliant with SAR regulations?
So SAR is a receive function. So yes, if you can refer to our reports, like which we can share. Let me state that this PowerHub is a reference design that's been developed by us, and every customer that has to take this technology, they will go through their own approval, but we will support all this approval. So this PowerHub reference design, we have not certified, but it is based upon a technology that is certifiable.
Okay, next up is there power loss if there's more than one single item being charged by the PowerHub, or is there an item limit of charging?
So item limits is based upon pretty much the physical space in which you can fit in, for example, 15 centimeter half circle. But there is another aspect. If you keep those devices very close, the antennas can impact each other, but they'll correlate, they'll get the same power. So you need to have a very careful antenna design so that these devices can not correlate with each other a lot and get power. So yes, the physical limitation and antenna design is important. But what was this other question? Sorry, Gordon.
Oh, I have to look back at that one.
Okay, sorry, go ahead.
Next up is, with always-on charging, do you envision as a selling point for device manufacturers, perhaps smaller batteries needed for these devices? Will milliamp hour capacity be a thing of the past? That's how we look at it. For example, I mean, we have been, I can tell you an anecdote. I was talking to a key fob company for the car key fob, and we were talking about that you can charge these devices. And one of the engineers said in the meeting that, but why do I really need to worry about it? Because my battery lasts for 6 months. But if you look into it, then the perspective can be quite myopic, right? There is a limitation on the functionality. For example, I cannot put an LCD screen on key fob, or I cannot have it always voice enables on the key fob because it uses more batteries. So yes, you can actually have a higher battery or bigger batteries, but you also need to think about what functions you could have put in if a continuous charge or a regular charge option is available, that your key fob can be charged while you're driving from your console, or you can bring it home and it can charge from a smart speaker at your desk. Now you can have LCD screen, you can have different kind of functionality enabled, which was not possible with a single battery.
Yeah, I would just want to add here, Neeraj, on the battery aspect. Yeah, I think battery anxiety or replacement of batteries is one of the biggest challenges many of these small device manufacturers are facing. And also at the same time, replacing the battery, whether it could be somewhere closer to you or very far off on a ceiling, like IoT sensors. I think that is one key segment. And I think with this evolution of wireless power, distance charging, for example, you can really take care of all those things. And in fact, your design of your product will be much, much better or quite different whenever you are taken care of from a battery aspect, I would say.
Great. Okay, another question is, what are, if any, some of the EMC challenges that you might have come across?
I think it depends upon its EMC challenges are no different than the other RF devices, and you need to be careful in how you design in 900 megahertz. For example, the antenna design is very crucial. Energis antenna team has come up with very innovative fractal antenna designs, and we have filed a lot of patents around that. That allowed us to have a smaller antenna at a higher frequency band like 900. You need to make sure that the antenna design at 900 and 2.4 gigahertz can coexist with each other. And I think the transmission, so higher the power, the better the isolations needed. So these are standard RF techniques, but here the focus is more upon how you efficiently transfer the power. So any kind of loss may be challenging. So I think system design is very important.
Okay, another question is, can this transmitter technology be embedded into other wireless devices? For instance, may we see phones or tablets that can charge perhaps a stylus or another small device?
Yes, so answer is yes. If you look into any phone or tablet, they have 2.4 gig, they have NFC for the different kind of use cases. They have the Wi-Fi, they have the cellular band. So multiple frequency bands or multiple RF frequencies are available in these format. And we believe 900 can coexist with that. And most of our approval are stating that.
Okay, also, which consumer electronic verticals do you see getting excited about uncoupled RF wireless power transfer?
I will defer that to Dinesh. I think I would like to hear his thought. He sees more things more than us. Dinesh, what do you think?
Yeah, sure. Thanks for diverting this question here, because I'm really excited when I speak to some of the companies about the wireless power market opportunity. And again, when you talk about when you talk about very low power applications, when you talk about long distance charging, there's a big range. In one of my slides, which I showcased, the applications within the mobile ecosystem devices, the medical applications, the computing devices, like we mentioned about the stylus or the tablet here as well. There's an opportunity even in the car in-cabin segment as well. So it is wide spectrum across industry sectors. IoT sensors is one big market. Smart home sensors is another big market for the segment as well. But at the same time, depending upon any devices which basically require less than 5 watts solutions, it surely kick in for a long distance charging as well. Equally, it all depends upon the designs, how you integrate a solution into it. But yes, the technology is available there.
Thanks, Dinesh.
Great, and we're coming up to our 10 o'clock time. This concludes our May 2020 webinar on the WattUp PowerHub. We'd like to thank you for sharing your time with us today, and we look forward to having you join us again on June 30th. More details on that webinar will be posted on our social channels and will be available on our webinar page. Thank you again for joining.
Thank you, and please keep on sending your questions, and we'll look forward to you on the June's webinar. Thank you. Bye-bye.
Sure. Thank you, everyone, and have a nice day. Bye-bye.